Conditional probability. So the conditional probability gives the probability of an event given that another event already happened. So let's say, for example, we have an urn, and an urn contains 10 marbles. 5 are blue, 3 are red, and 2 are white. 2 marbles will be selected from this urn, one at a time without replacement. Let B, let B be the event. The second marble that is selected is red. And let A be the event when the first marble that is selected is blue. The probability of B given A, that is how you read this, The probability of B given A. So if we were to put that in words, this is the probability that the second marble that is selected is a red marble, given that the first marble that was selected was blue. And this selection is done in such a way that there is no replacement. You draw one, you keep it, and then you don't return it back to the urn. And then you draw another marble. Another example. So the experiment is about drawing 2 cards from a deck of 52 cards. You will draw 1 card after another without replacement. Let A be the event an ace of hearts is drawn. Let B be the event a red card is drawn. P of A given B, that is how you read it. P of A given B. This is the probability an ace of hearts is selected given that a red card was drawn in the first draw. Again, an example of conditional probability. So this is our notation. P of A given B. And this is how you compute for this conditional probability. The probability of A given B is equal to the probability of A intersection B divided by the probability of B. So something like this is taking place in conditional probability. You know, when we were computing for probability, we look into the sample space. How big is the sample space? How frequently is an event observed in that sample space? In conditional probability, we are not paying attention to the entire sample space. This is like the entire sample space. We are paying attention only to B. B already happened. So if this is B, we are interested in this. This is A. This is the event when A happened. But we are concerned with what is the probability of A given B. This is the part of A that is in B. And so we will focus our attention only in this part, in B, given B. B already happened, so we are restricting our sample space to B. And then the probability of A intersection B, the part of A that is in B. Example, the probability a student is absent on a Monday is 0.03. So another way of saying it is Monday and the student is absent. And the probability of that happening is 0.03. Find the probability a student is absent given that it is Monday today. Let us define our events. Let A be the event a student is absent. Let B be the event when it is Monday today. So A intersection B is the event when the student is absent and it is Monday today at the same time. So the probability of A given B is equal to the probability of A intersection B divided by the probability of B. So let us describe the event A given B. So this is like The student is absent given that it is Monday today. A given B. And so P of A given B in words is, what is the probability this student is absent given that it is Monday today? And it is equal to this. So P of A intersection B is equal to 0.03. And then the probability it is Monday today. Okay, so we are assuming here that there are 5 class days. Monday, Tuesday, Wednesday, Thursdays, and Friday. So Monday is just one of the 5 class days. So it's the probability of B is 1 over 5. The probability that the student is absent given that it is Monday today is equal to this. 0.03 divided by 1 over 5 or divided by 0.2, and that is equal to 0.15. Teacher Jocelyn gave her students two tests or 2 exams. You know what? I kind of have difficulty pronouncing S and T. Okay, 2 exams or 2 quizzes, one for math and another for English. 25% of the class passed both the quizzes in math and English. 40% of the class passed English. A student is selected randomly from this class. What is the probability the student passed the math quiz given that he or she passed the English quiz? Again, this is how we describe it using Venn diagram. Let A be the event the student passed math. B, the event when the student passed English. So this is A intersection B, the event when the student passed both quizzes. So we are looking for the probability the student passed math given that he or she already passed the English tests. Okay, so this is P of A given B. So let A be the event a student passed the math part or the math quiz. B is the event student passed English. So A intersection B is the event the student passed both math and English. Find P of A given B, the probability a student passed math given that he already or she already passed English. So we are given that 25% of the class passed both math and English. So if 25% of the class passed both math and English, then if you were to select randomly a student from that population, the probability that that student that you chose passed both math and English is 0.25. Again, 40% of the class passed English. So if you were to pick a student randomly from that class, the probability that he or she passed English is equal to 40% or 0.4. P of A given B, the probability a student passed math given that he or she already passed English is equal to this. The probability he or she passed both math and English divided by the probability he or she passed English. So it's going to be 0.25 divided by 0.4, and that is equal to 0.625. Conditional probability and contingency tables. A contingency table is a tabular summary of a frequency distribution of 2 variables. A contingency table can look something like this. Okay? So this is like a summary of a survey. The population or a sample is divided into 2, male and female, and we ask them, are they in favor of divorce or not? This one would be a survey about the preferences of adults for Hollywood movies. Okay, where are they watching their movies? From Netflix, HBO, or AXN? I am not sure if we still have AXN. Okay, I have not seen this two channels in a very long time, ever since I discovered Netflix. So this is how a contingency table look like. It is a summary of a frequency distribution of two variables, and of course of our observations involving these two variables. So let A be the event a male is selected from the survey, or the respondent that you selected is a male. Let B be the event the respondent that is selected is a female. Y is the event when the respondent that is selected agrees with divorce, and N is the event when the respondent that is selected does not agree with divorce. Find P of Y given B. So how do you say it in words? Y given B. So that is the event the respondent that is selected agrees with divorce, given that the respondent is a female. So that is Y given B. Okay? So the probability that the respondent will agree with divorce, given that he or the respondent is a female, is equal to this. The probability of Y intersection B, the respondent is agrees with divorce and she is a female, divided by P of B, the probability that the respondent is a female. So how do we compute for this? So again, we can use your frequency method. What is the probability of Y intersection B? Okay, it's the event when the respondent is or agrees with divorce, and at the same time she is a female. So we will look into this. Okay, this one would be the event when the respondent agrees with divorce, and this is the event when, okay, actually this column is the event when the respondent is a female. So their intersection, Y intersection B, is this. How many of them are there? It's 10. So 10 divided by the size of the sample space, which is 200, okay, all over P of B. The probability the respondent is a female. We have 100 females, and this is our sample space. So P of B is 100 divided by 200. And this is equal to 1 over 10. We will arrive at this same result, 1 over 10, if, okay, look at this. So this one is Y given B. So it's like we shall restrict our attention to the smaller sample space when we are given the respondent to be female. So we will focus only in this. Okay? So it's like your sample space now is 100. So how many of the 100 agrees with divorce? You have 10. And so P of Y given B is 10 divided by 100, which is the same as 1 over 10. Find P of A given Y. What is the probability that the respondent that is chosen is a male? Look at that. Given that the respondent that is chosen agrees with divorce. Okay, so that is how you say it. That is how you interpret this notation. P of A given Y. And it is equal to this, the probability of A intersection Y divided by the probability of Y. What is the probability of A intersection Y? This is the event when the respondent is a male and the respondent agrees with divorce. So male and agrees with divorce. So their intersection is this, 30. So P of A intersection Y is 30 divided by 200. And P of Y, the probability that the respondent that is chosen agrees with divorce. So this is the part of your sample space that agrees with divorce. There are 40 of them. So P of Y is 40 divided by 200. Look at that. And simplifying this gives us 30 over 40 or 3/4.